Thank you everybody for joining. Welcome. This second talk is going to be about observability. If you remember, two things were announced. Second one is about driving bicycle. Just in short, what we're gonna go through. First, we're gonna do some intro options on the market, how to pick what is optimal for you, and who and how should get involved. So what we will not cover today, among some other things, there are security observability, there is data observability, cost observability, all kinds of things which are very, very important and crucial, but today we don't have time for that. About me, as my good old friend mentioned, maybe I should drop this year, but yeah, this is what we are, grumpy old guys. And lately, at least past 10 years, I've been working, not willingly actually, but accidentally more and more with AWS and Kubernetes and service mesh stuff. And not because I was always dreamt, I want to be DevOps or something. I do not describe myself often as a DevOps guy, but because I wasn't happy with how some people who should take care of things, how much automation, how much care they given. So I just rolled up the sleeves, and this is how I begin. So yeah, this is a very honest chart. This is the part where I'm trying to figure out how much of you actually are blue guys, brown guys, So please raise a hand if you heard about the term observability or you ever, okay. Raise a hand if you believe you have good explanation what it is, or you use it like on daily basis in your daily work somehow. Either like a product guy or DevOps or in whatever. I would hope so, because otherwise it's really tricky to ride the bicycle, indeed, blindfolded. Yeah, but actually there are some guys in India who do just that. I'm not saying it's impossible, but just it can be tricky. What is observability? When you go to Wikipedia, it says, it's a measure of how well internal states of a system can be interfered from knowledge of outside. And I would just add one important thing, which is without the need to actually break the thing up and just actually change it on the fly. This is very important. You hear something strange about your car and you need to stop the car and then smash the hood and, I don't know, start tearing pieces apart. Of course, you can understand what's going on, but that's actually not high level of observability. Ideally, you would just get some nice blinking icon in your seat and you just say, okay, your oil is due to change, and that's it. In short, how well you can understand complex system from outside without need to interfere with that. We can also say that observability solves very important problem, which is getting to know what's going on with some world that you care about, which can be some complex product. I would like, just to go through things and how I believe they relate to observability concepts, which we will mention later on. We have facts. Facts are just, like things we can observe without any additional instrumentation, any additional observability tools. But also we know we have things that we know that we don't know, which are questions. And for typical digital products, we can ask some questions through gathering all kinds of logs, APM, metrics, tracing, and then we store this data in one place, and then we shoot questions on top of this data. But also we have things that we don't know that we know. And those things we should put on dashboards, just so we can familiarize ourselves over the time and to build our intuition about system. Because some things are not easy for humans to internalize. Like it's too many moving parts. It's not always obvious which set of variables impact the system to go from state A to state M and then back to state C. Dashboards or some other things which will be mentioned later on can help with those kind of unknowns. And also we have things that we don't know that we don't know. And those kind of things actually demands exploration. And any solid observability tooling, modern, should critically enable for exploration. So what is exploration? Exploration is all the things above combined. So you can ask any question, you can get notifications about things that you didn't know that would go wrong or will go wrong soon if you do nothing. So what kind of data we actually have and we collect? So as we mentioned earlier, we have logs, which is probably one of the oldest way of having some production observability. You just accumulate all kinds of logs. Ideally, if nobody cares how much data you accumulate, then you store everything like traces, debug everything. It could help to debug things. Metrics, storage-wise, it's orders of magnitude more efficient, but still, you have to understand the metrics are just some data points about some counter or some gauge, like, what is the some value at some point of time. And, it's just another pillar of observability. It cannot, it cannot replace logging. So logging still is most versatile and most pretty much irreplaceable. It can be reduced, but only through logs you can understand why things break down, especially at application level. And then tracing is special kind of logs. So you have logs, you trace whole path of user request where you pass in context. So when something clicks on some website or loads page, and all services which are included, which should serve that request, are actually getting this context. It's usually some kind of long string, which is unique. And then you just store, instead of like just storing logs as they come, you store traces, which is also some kind of log messages. You send them through a special API called the tracing API, and you are able to visualize them nicely, to see like which database call, how much time it takes. If you haven't used any kind of tracing tool, something's very similar to that, which you probably experienced, is networking exploration in the browser. So you can see which request and sub requests took how much time, which job in the browser. So something like that. Monitoring is next thing. So when you have all those data, then you can monitor things on top of that. And you can aggregate derivations, create dashboards, threshold management, usually some static. And then on top of that, you can create all kinds of alerting, ideally automatic alerting without need to specify like, okay, please alert me if these things go over value X. No, just ideally you would say, if anything out of ordinary happens, please alert me, or alert like some group of people. So in short, observability, it actually requires all those three things, but much more than that to actually be modern, effective tooling, which some serious and complex product can depend on. So what are the options on the market? There are really like whole zoo of all kinds of options, like system monitoring, like we all heard about Nagios. Some tools repeat themselves, like enterprise level tools usually cover all those things. Time series it's not monitoring, it's just time series databases which are optimized to take a lot of data inputs and store it in an efficient way for later. Most of those tools are actually open source, like Zabbix, like Elasticsearch. Many of those actually are not open source, but most of them are actually based heavily on open source software. Let's take a look how some very basic observability setup could look like. We will start with logs management with Beats, which is like ELK stack, like Elasticsearch, Logstash, and Kibana. So Beats would pick up files from some Docker instance, from some pods, efficiently ship them probably most likely through Kafka, for example, just for availability, and then transform them through some Logstash transformations, maybe, and then put them in Kibana. I'm not sure if it's totally available in open source, but in paid version of Elastic Stack, you can track APM, you can have all kinds of anomaly detections, just counting some, like 500 errors or watching what is the response time. So you can create metrics on top of logs, which is not most efficient, way to do, but still it is possible. Proper way to track all kinds of metrics is actually to use Prometheus. It's probably most adopted and one of the most active open source and CNCF project for metrics gathering and analysis. And then Grafana is one of the most adopted open source graphing tools. Also very, very versatile. There is now a whole company built on top of Grafana called Grafana Labs, and they're doing really well. So now they have, like in Serbia, they have a Loki for logs, whole tooling around that. I predict really bright future for those guys. So with a very low licensing budget, you can set up for some startup like day one, just some simple observability pipeline and just get things going. It's all good, but after some scale, certain things become not so easy to operate. When you go over a few terabytes of log data, and usually you need 1 week, 2 weeks, sometimes even more of log data. Sometimes for some jurisdiction, they require like you need to keep certain kinds of logs available for certain time. Sometimes it's just for the team to properly investigate what happened if we catch some errors later on. And operating Elasticsearch clusters with even a few terabytes of data, not to mention tens of terabytes of data or petabytes, can be very tricky if it's not paid license. And even if it's paid license, there are many problems which could occur. So you would definitely spend a lot of time trying to tune shards, cluster, type of instances, you name it. Like it's really fun if you aim to be expert in Elastic, like just knock yourself out. Next thing, this is just few things. There are probably like hundreds or more that come to mind, which burned me recently. Next thing is scaling Prometheus to multiple instances is not trivial. There are Cortex and few other open source projects which aim to solve that problem. None of those is actually stable yet. It's some incubating CNCF. When I talk with some big companies which are using Prometheus, so what they do, they actually don't have a single pane of glass for all observability. They actually have one Prometheus instance for one application, and then each application they only care about what's going on with there, which probably it is good enough. But then you miss, to correlate what's going on, how your application is impacting my application and what's going on with the neighbors at the same time. So it can be tricky to scale. Then stitching all those things like logs, Prometheus metrics, Grafana dashboards, then Jaeger or Zipkin traces, and then correlating those things. In theory, now it should be possible because there is open telemetry, but it's not so easy. It is easy to take a look at one aspect of the observability at a time for one application, no problem. But scaling things for like multiple teams, it's a lot of pain. And then also another thing with open source observability, 2013, there was an open source project, very promising from Etsy, and I was super interested. I wanted to run it. I don't know what happened, but they just stopped development. Probably they pulled it. They stopped open source development. Probably they made some closed source solution. So right now there is no very critical part, which is automatic anomaly detection, which means look around what's going on, metrics, traces, and whenever you see something goes out of normal, out of expected values, sliding window counts, whatever, alert. Typical enterprise observability platform actually covers all of those things which are mentioned. I'm not paid by those guys or anything. It just happened that was appropriate solution for one big fintech company, which was adopted in past year and is still being adopted. It's not small work to actually push like hundreds of developers and multiple teams, multiple continents to actually start all using some big tool. Good thing about enterprise level solution like data, you heard about Datadog, New Relic, AppDynamics, Dynatrace here. Those guys cover everything like infrastructure monitoring, applications, microservices, logs, traces, even security, digital experience, like end experience of the customer. So you can say, okay, please take a look at 1% of all customers around the world, and if you spot something strange or it's slow, report back so we can do something about it. So you can have very early alarm system. Something is business analytics. It's even more close to business than digital experiences, and cloud automation and integrated into everything around, like Devops, CI/CD, security, of course, and everything else. And this is how one tool, which shows like this is data, costs, processes, services, and then applications. And then you can see like, okay, this guy here is, acting very weirdly. Something is wrong, and you can, just with few clicks, you can dive deep and you have usual solved already for you. When you have a pager, like something is wrong, you already have like a root cause analysis, and it tells you like, okay, most likely you should take a look at this, solve the problem, and then later on you can figure out what is the appropriate solution long term. Potential issues with those kind of tools, pricing. Those solutions can be pricing. So if your product is not very, very profitable, that can be an issue. Another thing is, if you already have some profitable product and you need to evaluate enterprise tool, it's not so easy to estimate how much licenses will cost you. Those guys, they try to be as transparent as possible, but it will cost you probably 50% to 100% more than you anticipated. Another thing, you should be careful about lock-in. So steer away from any non-open standard things. And cost of implementation can rise very quickly. So one thing is to have like day one, to have quick wins and to solve many problems, but then like you realize, oh, but to have full value, we need to customize this, customize that. And if you go through that rabbit hole too deep, it can get very, very fun. This is actually from Alice from Wonderland, when the catter asked Alice, so, okay, which road should I take? And he asked her, okay, but do you care where you were going? And she said, not really. And then any road is actually equally good. So if you don't care, like you can totally skip the rest. How you should pick appropriately solution. So if I was a salesman from previous company, I should say, of course, like pick us. But I don't work from them. Kidding aside, so you should always start not from what is the hottest latest thing outside, just to put like, now I'm like observability / AI ops expert because I implemented something really cool, and your startup is actually it's not profitable yet, or whatever, some other problems you have. Start with your actual problems. If you don't have problems, everything is fine, customers are not complaining, do nothing, literally, like, do not waste time. Some of the example problems could be this. Our customers often report problems to us, so it's them discovering something is wrong and then complaining on Twitter, and it's not so good. Medium time to recovery is too high, because of Google and some big guys. People now are accustomed to have really high availability, performance to be really good. And when things other outside of FANG are not working like totally flawlessly, they are disappointed, which is actually a good thing, just keeping bar the high. So this can be problematic, and then business can say, okay, we are not happy with that. We need to improve. Let's look how we can improve it. Churn, because of those things, churn can go high. So people, customers going away. Product does not understand why we need refactoring. Yeah, this is another thing. Product guys can just keep up piling up features and never go back to actually pay some technical debt. When you have some nice observability in place and you can show them with nice graphs what's wrong and why it's wrong, then it's much easier conversation. Yeah, this is another reason why you can take this journey, but I'm not sure it's optimal. So this is some space, low budget, high budget. On the left, you have some small operation like startup. On the right, you have enterprise, some big company. What kind of observability stack you should think about? When you are broadcast startup, you should, first of all, you don't have a big complexity yet. So you can start with what you mentioned, ELK, Grafana, Prometheus, should be enough. Next, when you are startup, but you're still well-funded, you can probably start adopting more serious things like Kubernetes, service mesh, premium solutions like maybe Datadog, or some things which allow for lightweight and not so steep cost. And if you have money and if you have a complex product, I would urge you to think about investing in those things as early as possible. Next is when you are like low budget, but like a big company, then you need to use mostly open source tools if you want to avoid some steep licensing. But then you need to understand there is most likely a lot of need for the custom development, stitching, and putting things together, which could push total cost of ownership even higher than when you just adopt some off-the-shelf enterprise solution like New Relic, Dynatrace, AppDynamics, Datadog, or something like that. Latest Gartner APM report puts Dynatrace, AppDynamics, New Relic, and Datadog as the clear leaders. But look, this is just one report and just for APM. I strongly urge you, whenever you make some decisions which are costly to change later on, first of all, you need to pick questions which can help you to choose the proper solution. Those things can include how well this thing integrates with everything else that we have, how well it supports our most critical problems, how well it supports our strategy for next 1 or 3 years. Integration with other tools is probably very often not considered seriously enough, in my opinion. And it's one of the most critical things. And then lastly, who and how should get involved? Obviously, we should start with sysops, network guys, all kinds of people like that, which we shall not call Devops. SRE, like people who are responsible for the production systems. DevOps, like I was just trying to explain to my wife this presentation before, because I had to be sure, like somebody who's totally outside of technology can understand. And then I caught myself explaining DevOps, it's not like a job description. Just forget all companies put like we need DevOps engineer. It's not that. It's culture. It's everything. But yeah, whatever we can wish world to be different. But there are some DevOps people. I heard. Of course, developers, incident managers, and guys like that. Pretty much all of those people could get awakened during night. Those guys are very rarely awakened during night, but they should also be awakened, so they should care a little bit more about all the things, and then they will get more involved. They should be included. Customer support, product owners, and security. Product owners, why? Because then they can have much better touch with the product. Ideally, all of above, plus business guys and data science. Data science, because when you have some professional product which already has some AI included, it is still beneficial to have your internal data science guys to be included and to produce some kind of correlations. Because if you have time, resources to invest into understanding what's going on and how things can be improved, this is nice for machine learning and data science. This is just one view from most obvious and most often taken usage for the observability when something goes wrong. There is some monitoring, and then in some incident response, like sysops, SRE response. There is postmortem based on this data, and usually any of those professional tools, they will have like problem with whole context, with root cause analysis, with everything that happened, everything will be saved. And then you can have testing and release procedures. So one of the most powerful things which I'm advocating for is to include observability tools to shift them as left as possible. So much earlier than production, you should be able to get some warnings that performance-wide low testing or something like that is not working as expected. And this new release has some possibility to downgrade some certain SLOs, service level objectives. You can test all of that even before production. And this can help you with capacity planning. So just imagine you want to launch something new, or like you want to put some new campaign with existing product, but you have some Super Bowl or Christmas or anything. So by testing things and observing them, you can have at least some kind of estimation what could happen. Of course, developing the product, they need to also be evolved. Do not get yourself locked in. So try whenever you adopting things, use open and popular standards. So it's not enough to be open like open facing. Now it's pretty much obsolete. A new kid on the block, like from a few years ago, now it's really well adopted and implemented by most of those big guys. It's called Open Telemetry, and it covers, like, of course, tracing, but also logs to correlate logs with the traces and everything, and metrics. So it's one big standard for support for all kinds of libraries, frameworks, languages, and so on. Be sure that whatever tool you adopt is actually supporting some open standard. Take into account total cost of ownership, not just initial cost of installation and setting things up. Try to estimate how much things you would get out of box with this solution that you like most, and how much you would need to actually re-implement, customize, maybe engage some third-party consulting or whatever. So it's better to ask this question earlier than late. Also, think about having one agent versus per language libs. So some companies, because of feeling of control, they do not like to have too much magic packed into one agent, which will just automatically inspect all the whichever host you put it, like it's just understand, oh, now I'm running in some MySQL database. Oh, here is like Java process with Spring Boot and this version, and here is the Golang this, and automatically it will rediscover things and pick up all the metrics, APM and everything. Some people need more control, more customization, and they prefer to go like language, like to include, like to change source code and include manually libs. As the case, it's up to you, but I would strongly advise not to waste time and to go with agents which are capable to inspect things automatically, and only then, if you are not seeing some very custom things, then start pushing some custom metrics and stuff like that. Even if you push custom metrics, don't do some custom thing which this vendor actually is their own thing. So you can switch much easier later. When you're doing, like, for example, traces, if you just decide to trace everything, first of all, you need to invest, like you need to instrument code, and then most likely network traffic will double instantly if you just trace everything. That's one thing. Another thing is, if you want to store all those traces, it's actually just logs, as we mentioned. So it will require a lot of storage, a lot of cost. Be smart about tail-based sampling. What is tail-based sampling? You just sample everything, and then just before you store traces, you have some black magic to decide which traces are interesting, and then store only them. Like usually it's 5 to 10%, or maybe even less. Also, pay attention to how well chosen tool integrates with others. Yeah, I already mentioned this. This is very important. Without this, it's very hard to involve all roles which are needed. Pay attention to pricing model, total cost of ownership. And now I'm talking about premium tools. Some will have a pricing based on cost, some based on data transfer, or maybe host size, and so on and so on. Pay attention how much out-of-box artificial intelligence will solve problems instead of some tireless humans which you expect to come around some dashboards and spot if something is wrong, and then put appropriate fixed thresholds. Because business changes, like weekend traffic is one thing, Monday, Friday is different. If you have appropriate AI in place, which will just learn what is normal and alert you only when things go off, it can help you a lot, immensely. Try to get as powerful as you can pay for this thing. It can pay off very quickly. During POC, aim to get as much as possible value week one. This is especially possible with when you have one agent. You just put agent on host, you just put them in Terraform templates. In next rebuild, they will be deployed, and you just start getting all kinds of observability to the dashboards and value out of box. Why this is important? Because any organization, it's a live organization, and there are humans, and humans are best known to have habits which die really hard way. So best way for those habits to actually push across the nice edge is to show them some more beautiful world. And the best way to do it is like, guys, look what we did like in just a few days. Like, isn't this magical? Of course, like much more work will be needed down the road, but if you have really good results early on, adoption is much more likely, effective adoption. invest heavily in education of all roles mentioned earlier, because if people do not learn early enough how it will benefit them to be more effective and to get the raise, why should they care? Start with Kubernetes if you can, because Kubernetes right now is so dominant that all those toolings, they work perfectly with Kubernetes, and they start to neglect everything else. This is the situation, this is the reality. Add service mesh if you can. It can help you with security. It can help you with all kinds of network visibility, especially if you already have Kubernetes in place. And it can help you with observability overall. Not just observability, but it can help you automatically with networking problems, redistribution of load, security, MTLS, all zero trust environment, and so on. And also, it will definitely simplify applications and microservices. So you don't care about retries, about what happens if this guy is not listening, if it's down. You just push all that logic to service mesh, you have a nice control plane, and then you build additional observability on top of that. It is really powerful. We can always just have a nice tool which tells us everything is fine, nothing is broken, as Alice also asked. So, of course, you can decide not to care about any of these, but then if you are some stakeholder into some of those products, or you just care this product being successful, it can be tricky. That's all. So thank you very much. Now it's time for questions. Yes.
What do you currently use?
Different projects, different things. So for smaller products, we start with monolith or few services. As I mentioned, it's usually ELK, Prometheus, Grafana, and that's it. At one place, it's big fintech company. They have a bunch of teams around the globe. Dynatrace was actually adopted as best solution, but I'm not saying Dynatrace is best for everybody always. I can explain why we calculate it. It's there because it is one agent. It's not like New Relic, so you need for Java this and for that. It simplifies things a lot. And the other thing is it has really powerful AI engine behind, which will conclude all kinds of things, what's going on wrong and why. All that being said, after some months in production, everything is not great. So if you go to RFE, you can see my name, a request for improvement for all kinds of things. Main reason why it's not so smooth is because not all the workloads are running on Kubernetes. Otherwise, it would be much easier.
One more question. For instance, you talked about properly about observability. You set up ELT. How hard and tricky it can be to transfer, to make a transition into a paid or enterprise?
Really good questions. It can get costly, especially if you already invested a lot of time, but it doesn't have to be costly. Major value that you get from Datadog or New Relic or Dynatrace is not about just logs or maybe there's some really basic APM in ELK, but you get all other things. So the last thing that you get to replace is just to ship logs. Okay, do not ship logs to Elastic, ship logs to Dynatrace. And one last thing you need to do is to somehow correlate logs with traces so you can match them. When you need to calculate, do you need to move to something more professional? Calculate how much money you're losing for each minute or each hour of some critical system being down. And then it's very, very nice argument for any CFO or CEO to consider something which can cut this time 5 times or 10 times. Start as early as possible. If it's open source and if it's open telemetry, then it's very easy to move to any of those vendors.
Okay, so let's say you really have a lot of logs and you've been saving them for years. For example, we use Glacier in AWS, and from the data flow from Kafka to Elastic, okay, and saving some of the logs is going through Kafka Connect S3, let's say, to S3 bucket. What would be other approach of those kind of logs that you will need when you save them?
Glacier is very, very common place to dump. So, for example, there are hot nodes in Elastic cluster. There are warm nodes, which are much worse performing than Elastic is actually claiming. So yeah, you get one order of magnitude worse performance. After that, you dump things to S3, and then after that, S3 should roll over to Glacier. And usually it's for some regulatory needs. If you're already working a lot with AWS, I don't see using Glacier as a problem. It's always balanced, between cost and performance and regulatory needs. Thank you again for coming. As Mariana mentioned, we plan to have a bunch more of those events in the future. You're all welcome. We plan to get some serious next time. Nice. Yeah. Again, thank you. And we can stop recording.